Hello everyone, my name is Benjamin Salem, and this is one of a series of presentations on industrial design, creativity and innovation, and it's about helping you have an understanding and a feeling for what it's all about. Obviously there are as many definitions as there are industrial designers, and it's a matter for you to make sense of it all and have your own understanding. So this first presentation is about design creativity, and we will go through what is a creative cycle, what is an invention, what is an innovation, what are the early stages of design, what is idea sketching, and what are unexpected discoveries. And although it sounds very theoretical, any of you who's involved at any point in any either industrial design or engineering design or even pure engineering project in developing a new artifact or a new system will get very quickly familiar with these concepts. So the creative cycle is basically how our artifacts, how our system, how our motors, how are they created. There are many ways of describing that, and hopefully you can see my mouse. My way of describing that is that there is a kind of a trinity, shall we say, of innovation, design and invention. So invention is about novelty, is about inventing something new, and that can then be translated into an innovation or translated into a design. And when you create an invention, let's say you invent a new way of boiling water, or a new way of generating power, or a new way of generating motion, actuating some motion. You are the inventor of that concept, like diesel was the inventor of the diesel engine, or like Tesla was an inventor in the field of electricity, to name some of the most famous ones. And they come up with novelty, but that generally is not what gets you to the market. A good example of that is that at Xerox, which is Xerox Palo Alto Research Center in California, they invented the graphical user interface, they invented the mouse, and then with David Engelbart, who then worked at the SRI, and they invented Ethernet, and they invented PostScript, but they were the inventors, they weren't the one who translated that into successful commercial ventures. That is generally done by the innovators, and the innovators in that case were Bill Gates and Steve Jobs, who visited the park and translated what they've seen into Windows and the Mac OS, and that became a success. So the end result of an innovation is success, while the end result of an invention is novelty. Now both will gain a lot if they look at design as well. And here design is about looking at how innovation can be adopted by a lot of users. So how to design something, how to design an invention to something useful. So looking at current issues, current problems, current needs that people have, or inventing new needs that people will have thanks to your product. Like now we're all obsessed with Facebook, when before we didn't have social networks. And creating a solution for that. So good design delivers a solution, and it takes an invention, create a prototype that then solves a problem, or we take an innovation and adopt it so that it becomes a solution for a problem. So you can see they're all interconnected, and the way to connect them is either via translations, adoption, or prototyping. And essentially what you need to understand here is when you're creating something new, you can be the inventor, but that's not enough to get into the market. You can be the innovator, but then you don't own the IP. But then you will have something that is successful. Or you can be the designer who then take either an invention or an innovation and then turn it into a solution that's going to be adopted by people. And they are all interrelated. And most of the time, in small projects where you have to create something new, especially let's say a quick and dirty project for conceptual project for clients, you are going to be the three of these at the same time. Right, so the creative cycle, what you need to retain is that the creative cycle including design, invention, and innovation, are interdependent and interrelated. They connect and they are overlapping. They're not clearly separated, but they are more or less the three parts of what creativity is about. You need a bit of design, you need a bit of invention, and you need a bit of innovation. The invention itself, and I do apologize if I make this complicated diagram, but I love making diagrams like this. So the invention is about taking something that exists in the world, to observe it, to extract from it a pattern or an understanding, and for example a measurement or the description of a phenomenon or the analysis of a process. And all that then gives you a very objective, a very declarative, very explicit understanding of what it is, and by reformulating it and by adding new ideas, you get into an invention. At the same time, then you do observation, you do then experience, you also gain an experience of what you observe, you also gain an experience of the real world, and through that you get an appreciation for some efficiencies, for some beauties, for some mechanism or patterns that you think are quite effective or efficient. And you try then to, you report that to yourself, you're like, oh, what's this that I like about this? Why do I like this wheel movement? Because it's nice, it's circular, and it's regular, and it will solve a lot of problems. So then you reproduce that, and you can see what is the gist of it that you like. And in the wheel is the wheel spinning, that you make you realize that if you invent the wheel, you can travel a long distance with little damage to your vehicle. So that creates a subjective and non-declarative implicit knowledge, which is like, yeah, I appreciate that. Why do I appreciate it? Because it's spinning smoothly, but it's beyond that. You appreciate the beauty and the simplicity of it. And you combine that with the fact that you need to carry something on a vehicle, or to have a vehicle that travel long distances, and then you realize that the wheel is a perfect invention, and that becomes your invention. I'm giving you the example of the wheel, but you can apply this to a lot of other things. But what you need to understand is there's two parts to it. When you're observing the world, when you're trying to get new ideas, there's the part which is like explicit, like using math, like using simulation, like using test trials, experiments, and you get of it very explicit, very declarative knowledge. And then there's the part where you experience it yourself, where you observe it, where you try to get some ideas, and that gives you a subjective and implicit knowledge. And it's the combination of the two. One helps you to be ready to pick up a good idea that you will see, and the other help you generate ideas that you'll be capable of picking up when you see. And so both work together to make you an inventor and make you deliver new ideas. So the invention is about generating new ideas, and it's an insight. It's an understanding of relationships, understanding of a pattern. It's an understanding of what's going on to help you solve a problem. So you need to have a problem. How can I carry some goods on the vehicle over a long distance? I need some sort of mechanism, solution, design that's going to work, and that's how you end up with a wheel. Okay? So the innovation is something else. The innovation is you have a new design that already exists, you have an invention that already exists, you refine it, you make some improvement, you add some new things to it, and through various processes of refinement, like iterative design, various methods of refinement, so better manufacturing process, various products you make prototype 1, 2, 3, 4, and then various devices. You make a working prototype, you make a second working prototype, you then create a demonstrator which then help you make a commercial product out of it, and from that people adopt your solution, and that gets success. So innovation implies that there is success. A good example of an innovator is Elon Musk from Tesla, who's not the inventor of anything, but he's very good at translating that into a successful product, like the cars, or like the reusable space rocket from X-Space. Other examples are Bill Gates, who didn't invent MS-DOS or Windows, or Steve Jobs, who didn't invent nor the touchscreen nor Mac OS, because all these came from Xerox PARC, and touchscreen came from somewhere else. But all the concept of the Mac will basically come from the Xerox Mac. So they took some inventions, some new designs from somebody from another domain, combine it and create a new innovative solution, innovative product that is adopted and becomes a success. So it's essentially the successful adoption of novel idea or novel solution, successful adoption of novel design, novel invention, and it's a process that takes integration of different ideas, different good products that already exist, or different good solutions that already exist, and combine them into something new. Take Tesla, it's touch screen as a dashboard, batteries, autonomous vehicle, semi-autopilot, which is in fact semi-autonomous vehicle navigation, all that combined into one product. So design something else, design and but it's part of this, and all of these combined allow you to be creative. Design, you have to start from somewhere, and design you start from a brief, which is generally what we do in an academic setting, or a client's need, which is generally what happens in a business setting. You also have briefs when you do a design competition, or there is a large public body who open a bid for a tender. So you have to tender a bid for a contract for a project. They give you a brief and you have to design something, and then if your design is the best, they'll take it, they'll adopt it, they'll accept it, they'll ask you to submit further prototypes or visualization or ideas before, and then you're the winner of the competition. With the client, it's different. You have client needs. They come to you, say, I need some mechanisms to carry a lot of goods over a long distance, and then you start making inquiries about what their exact needs are. You have the explicit needs, the one that they know about, and the implicit one, the one that are there but they're not even aware of that. Like, for example, that the vehicle has to be of a certain height so you can put carts onto it without breaking your back. They don't even think about that, but it's actually very important for their vehicle. And then you have new opportunities. You have, well, I can see that, for example, the keyboard is not working very well, and I'm going to design a new keyboard. Or so some personal exposure to problems, or a personal realization that there's an opportunity to design something there. The first thing you do as a designer, industrial design, mechanical design, engineering design, is that you have to visualize your ideas. So you do sketches, you do presentations, you do models, you do prototypes, CAD models. There are many ways of doing that, but what you do, you formalize your design into something that can be shared, communicated with the other, and reviewed as well. Once you've done your visualization, you then do your validation, and your validation, you do tests. So either you do demonstrations, you do trials, you do experiments, you do tests, you measure performance, or you ask people, potential users, to use your design, your prototype, your models, and see if it works or not. And that ends up being, once it's done, few of these iterations, once your ideas have gone through these iterations few times, and generally we should talk about a minimum of 4 or 5 times, and top professional designers will do around 20 to 30 iterations, then you have a final design that you're very happy with. And that's what design is about. So it's about solving problems, it's about delivering a solution that is unambiguously visualized. That means a solution that is clearly visualized, clearly explained, clearly communicated. And unlike other domains like pure engineering or pure science, there are many solutions, and a lot of them are equally valid. So there is a bit of a, shall we say, irrational, or shall we say, not really explicit but a bit implicit decision of which solution you're going to put forward. It's not, because there's few of them, you often come up with few solutions that are equally good, and then it's a question of style, or it's a question of other issues that you might decide how to choose one of the others. So that's very important in design, that it's not, there's only one way of designing, there are often many ways. So what's very important also to remember is that in the early stages of design, you have initial ideas that you visualize, and it's a source of creativity and innovation, because you go into that trilogy and you start with designing more and more, and then visualizing more and more, and that allows you to maybe become more innovative and it gives you more creativity, and that may help you invent something new because you start thinking, what about this could be a new thing. And all that is basically formulating problems, finding solutions, formulating new problems, finding new solutions, and so on and so forth. Start with simple things, and becomes, the more you're fluent in design, the quicker you go into these cycles, these iterations. Idea sketching are very important because they are about externalizing your concept and making your concept formal, so they're visible, they're communicable to other people. And that can be done with drawings, sketches, CAD models, clay models, cardboard models, prototypes, working prototypes, test prototypes, concept prototypes. And when you do that, you might discover new problems, you might discover new opportunities, you might discover new issues. So they are very useful. Sketching, idea sketching, in the form of drawing of sketches or models or prototype, are very useful to find new discoveries. They're often accidental, so there is often serendipity in the discovery of new ideas that will help make your design a successful one. But what's very important is that your design is not kept in your head. It's always externalized, and you make as many concepts as you have in your mind, and you make them physical, tangible, like they can be touched, they can be seen, they can be shared with others. And the other thing that this allows is for you to come back, to revisit, to reinspect, to reinterpret it, to rediscover, to reinvestigate all your ideas. So that's why it's important to always do it on the logbook or a sketchbook. Something like this need not to be more than this. And you can see there's a lot of different things, like there are some drawings of a wing profile, how to design, very simple sketches, but they're always on the logbook and you can always come back to them. Let me find you some good ones. Yeah, for example here, there's more here, how to design some parts. There's some here showing how two gears are connected. And before you know it, you keep all these, because you can always revisit, like for example here, how we design two parts, how they're going to be assembled. So you're always going to revisit. Okay, that's very important. That's why you need to sketch, and you need to formalize, and you need to record, and you need to keep. So logbook, any size, any type, find one that works for you. That's really, really important. Okay, and what's very important as well is that you end up with an that's very important, is that you make an unexpected discovery, and you have to be open to them. And they are often non-intended. They are often things that you didn't think about when you started, but suddenly it's like, whoa, that really makes sense. And that allows you to go further and create opportunities to go forward and back and create new design, add your new ideas, discover something new in what you've done. And that triggers new ideas that you want to integrate into your design, so you put them in, and then you come back to the sketch and you realize that with these new ideas there are new issues, there are new solutions that you can then integrate into your design, and this is the back and forth progress. So progress is both ways, forward and backwards. Sounds a bit paradoxical, but that's the way it is in most creative processes. And it's about shifting between clarifying design ideas and formulating design requirement. What you need, what you get. Your problems, your solutions. Requirements, ideas, sketches, designs, etc. And you keep doing that. This repetition is very, very important. So when you look at design, and you can see that how is design fitting across with all the other disciplines. My personal approach is to look at these 4 key disciplines: science, art, design, and engineering. So as you can see, an engineer is between a scientist and a designer. They take phenomenon and laws of nature, like for example thermodynamics, or like laws of mechanics, and they develop from that a product or a device. More likely a device, as in something that has a function. They do that looking for efficiency, and ultimately they want a patent on it, and then they want a company that's going to make that device. The scientists take the phenomenon or the law of nature, and that comes from the interpretation and the representation of nature that they observe, and that to do that observation they have to be objective. Their ultimate aim is to have publication, of course, to have a Nobel Prize. So they go from interpretation to a phenomenon, from representation of nature into a law of nature, like E equal mc square. Looking at the phenomenon, energy dissipation and energy in the universe, and realizing that energy is the mass of an object time the square of the speed of light. An artist takes some aesthetics and some experience and turn that into an interpretation or representation. So have an experience of a muse and give a representation of that muse in a portrait. They're looking for generating values, and ultimately they want to exhibit their art, and they want to have a patron like the Medici that will pay for their work, so they don't have to worry about it. They can just produce as much work as they want. Designers are in between the artists and the engineers, and they take aesthetic and experience, so design style, and they turn it into a product of design and a product or a device, and they are concerned with usability, because that's the key difference between designer and engineer, is that designers do have the end user in mind, not just in terms of ergonomics, but also in terms of usability of their product, usability of their device, what's the user experience, what's the interaction between the user and the device, what are the affordances the device has to make the user comfortable with using their device and confident with using their device. And they want to ultimately have a design studio, and they want a lot of people using, so they're looking for users, so that a lot of people are using their design, which makes their design successful. Engineers' work main criteria is demonstration, scientists' main criteria is peer review, artists' main criteria is critique, and designers is evaluation. So it gets evaluated in terms of tests and trials to see if it works or not. So engineers and scientists share the endeavor of trying to explain things, because the scientist explain and the engineer from that explanation draw efficiencies and avenues to produce the best effective device. Scientists and artists are about description. The artists describe nature, and the scientists from those descriptions can then draw conclusions about the laws of nature. A good example of that is zoology, where you had artists drawing all sorts of birds in different continents, and then zoologists from those drawings, from those portraits, could then classify animals and create a good classification, good understanding of the animal kingdom. That's one example. Designers and artists have a shared common expression. They're about expressing their views on things, and the designer express their ideas via the artifact, while the artist express it via their art. Artists describe what they see via their art. Scientists describe the laws of nature via the nature via the laws of nature. And then science and engineers try to explain things. Engineer with calculation and simulation to demonstrate that what they come up is good. And scientists explain what is electromagnetism, for example, by describing it with formula. And then engineer and designers have something in common, is that they both make. Some make devices and products that are highly usable, and other highly effective or efficient, but they both make things. So it's in the making that you have a connection between engineers and designers. And that's the end of this presentation. I hope you found it interesting, and many thanks for your attention.